Hi, I'm Alan Weckel from 650 Group, and it's my pleasure to be here with Sandeep from Marvell. We just got off a fresh Industry Analyst Day. You were talking about the Gutenberg Press, talking about information, and talking about infrastructure and interconnect. So can we just start there at a high level, right? A lot of information, a lot of good analogies you had. Where are we in this information, infrastructure, interconnect to get AI up and running?
Oh, thank you, Alan. It's great to be here. Yeah, I was always looking for analogies to make a point. I guess the printing press came to mind. It's all about information and data, right? And so since the printing press was invented to how the proliferation of knowledge happened, if you take that and add infrastructure that was built to proliferate it, whether it's electrification or the internet, that duration was like 500 years, 400 to 500 years. But now we are in the innings of AI where this information and dissemination of it with the AI infrastructure build out is probably going to happen in a decade. I mean, that's simply staggering statistic. And that's what excites me to be here and being at the right time, at the right place for an innovation that is, we are in the thick of it.
You've been in the news recently with your Celestial AI acquisition. Can you double click a little bit on CPO and what excited you about Celestial?
Yeah, certainly. And I will be careful on what I can disclose in this talk, but let's start at a high level. At a highest level, if today it's all about the connectivity challenge. So when you need to hop across two chips, you need terabits per second bandwidth. And if you have a single chip, whether it's an XPU or switch, you are dictated by how many bits you can pack at the edge of a chip, for example. And that's based on a SerDes speed of 100 gigs or 200 gigs per second. And because you have all these packaging constraints in a chip build, then you are limited by the beachfront as you can. And so there are different kinds of optics that are necessary, that different modulation schemes. So Marvell has had a very good portfolio on silicon photonics on the data center interconnects, which is for ZR and ZR plus optics, that is scale across. And what Celestial brings to us is really how do we ensure that optics plays a significant piece in the scale-up portion of it, and it has a different modulation scheme. The energy efficiency or power is equally important. So they have proprietary interconnect bridges. So it takes away the beachfront density because you have a 3D package that has a photonics fabric chiplet on it, which can go on the XPU or it can go on the switch for scale-up networks. So with Celestial's acquisition, we are able to not only have our scale across our data center interconnects with our silicon photonics, which is, with Mach-Zehnder modulators, et cetera, but we have another set of modulation techniques that can do within the rack scale or scale up, and that's what Celestial brings to us. So it's kind of a complementary set of technologies, and both of which are important all the way from scale in, scale up, scale out, and scale across.
Yep, I think we're here a lot more of scale in as we look into 2026 for sure. So maybe we can talk a little bit about custom. So you can't do everything that we've just talked about with just kind of bespoke parts, right? Yeah. So what's the role that custom ASICs, custom networking have in the AI world?
So in the design realm, doing a one-size-fits-all is not really the most optimal if you want the TCO benefit. Meaning, let's say in a rack, which is a switch, that is like 1,500 watts. Can we do it with a lesser reach and save 20–30%? That's very meaningful. Same thing with pluggable modules across racks. In a pluggable module for optics, there is let's say a 25-watt power envelope on the module itself. If it is 26 or 27 watts, it's game over. You really don't have a design. So these are aspects where everything is purpose-built, whether it's a data movement challenge, whether it is copper or optics, custom compute itself, switches for whether it's scale up or scale out. all this have a very important bearing on the IPs that goes into each of the chips that we design. I just talked about SerDes was one example. There is scale-in die-to-die interconnects. There is network on a chip and customized HBM interfaces, because memory is a significant piece of the design of the overall power distribution is equally important. Then it's all about packaging. Do we have the necessary packaging technologies for thermal spreading, materials research itself, the large reticle sized dies, how do you connect all these together? So that is why customization is important. So it is really a big system level design approach, all the way from silicon to package and beyond.
Yeah, I think you mentioned something that really strikes with me, which is, hey, if you wanted to do, say, like a 2-meter reach, and then the next standard is 100 meters, you don't want to pay that overhead for that additional distance, right? When you only need, say, 4 meters or 8 meters to go to the next
Correct.
rack. So customization could be just something as simple as enhancing a standard. And then you went to like custom processors, right? Where that's completely different. You're optimizing for the workload. So really it's about the right tool and the tool chest for each of those. It's not just a one size custom fits all.
Absolutely, yeah. And that is what is important for TCO benefits for the data center operators and the data center builders. And that is where Marvell, the way to think about Marvell is, whenever an electron leaves in the basic level from a compute element to all the way from a connectivity to a photon leaving and getting to the next data center, we want to be at the path of all this such that Marvell silicon can be optimized for best TCO.
Yeah, that makes a ton of sense. So how do you figure out what to customize? You can't customize every tool, right? Your toolbox would then be too big.
Any place where there is huge amounts of power to be saved, and I talk about interfaces and connectivity a lot because that's where bulk of the power is spent. And then there is SerDes and analog mixed signals, IOs are 50% of the chip die area. That's also probably greater than 50% of the power. So we take a real look at how do we optimize these complex data movement widgets or IP. So that's one significant piece. And as I was talking to you about packaging aspects and thermal, how do you manage thermal in complex packages? That's an equally important aspect, because it's not about power reduction. It is, do we have the ability to cool this with the right set of technologies? That's where packaging plays. In fact, packaging is more of important these days, as important as silicon design is. So that's taking a bigger role.
And then how does this impact tech companies, right? So we're moving towards AI, we're absolutely moving towards customization. So what does a tech company do to kind of stay with that innovation wave?
Yeah, it's definitely getting harder and harder because, as you know, Dennard scaling is dead, so you don't really get going from 2 nanometer to the latest angstrom node, whether it's 14 angstroms or what. You don't get the real scaling that we used to get before. So all that means that there's more innovations that are necessary at the architectural level, at the system level. And that's where I was saying that AI is going to be even more important in saying, how do you optimize at the front end of the architecture? We have tools that are in the industry and in the EDA ecosystem to look at time enclosure. Can we do it with lesser power? Shrink the cycles more, because what used to be 2 years is now product cycle times and now become 6 months.